Hello, everyone, and welcome to the GeekNarrator podcast. I'm your host, Kaivalya Apte, and I'm back with a brand new episode on this podcast. Climate change is a very serious topic, and we should all take it really seriously. But as software engineers, are we doing enough? Are we being conscious while making those coding and architectural decisions? Let's talk about this in more detail in the current episode. To do that, I have Yonis with me, who is the author of Green Software Book, and he's going to help us understand all the techniques on making our software more climate friendly. So, Yonis, welcome to the podcast. I'm really excited to have you on this episode, and let's start with a brief introduction.
Thank you, Cavalli, for inviting me. It's an honor being here and have this opportunity to speak to everyone about green software
Mhm.
engineering. I have an experience of 18 years as a software
Yeah.
engineer, building software
Hmm.
applications mostly in the Java ecosystem. And at some point, I was wondering, what can I do as a software engineer to help prevent
Yeah.
climate change? I was already doing some things like recycling
Hmm.
garbage or using public
Mm.
transport to help reduce carbon emissions coming from transportation
Yeah.
from cars. But I couldn't uh, see how I could help contribute with my work as a software
Yeah.
engineer to preventing
Hmm.
climate change. And one of the main tasks in my work at some point as a software architect of a complex software
Hmm.
solution was to reduce the costs of this application while running
Yeah.
on cloud. What does it mean to reduce the costs? Cloud providers charge us depending on the CPU usage, the memory usage, the network traffic that
Yeah.
we consume. So all my efforts were around reducing the consumption of CPU, RAM, and network
Mm.
traffic and
Yeah.
and storage. And at some moment, I realized that our applications, our software applications, run
Mm.
on servers, and these servers consume
Yeah.
electricity. And how do we produce
Mm.
electricity? We commonly burn fuel like oil, gas,
Yeah.
and coal, all of them producing high carbon
Mm.
emissions. And as we know, carbon dioxide emissions are the ones responsible for climate
Yeah.
change. So, by designing our applications to consume less
Hmm.
resources, less CPU, and so on, we can reduce the electricity consumed by our
Yeah.
applications and therefore reduce the environmental footprint that our applications
Yeah.
have. And that's how I started. I actually looked from a different
Hmm.
perspective, from a different
Yeah.
angle at all the practices I already applied in my daily job
Mm.
in reducing cloud costs. And this is how I began building green software.
Yeah.
So by reusing these practices and gradually I started building on top of these practices with some practices that are
Mm.
specific to green software engineering.
Yeah. Very interesting. So as you mentioned, so we software engineers usually look at optimizing solutions, mainly around the CPU cycles, the memory usage, the storage on disk, the network I/O. But as a side effect, we might also get a good impact on the climate change, right? Our software will have like a less carbon footprint. So that's a very interesting perspective to look at things, and I think it's a good motivation to optimize our software around that. So yeah, thanks for being here and thanks for the introduction. Let's talk a little bit about your book on green software.
Yes, at some point I wanted to share the knowledge I
Yeah.
gained in this field by writing a book. On purpose, I wrote a short book that someone can
Hmm.
read quickly to get
Yeah.
quickly on board, to become familiar with all
Hmm.
these practices, and make an impact quickly in
Yeah.
the daily work in helping prevent
Hmm.
climate change. Uh, It's a book that provides practical advice for software developers and software architects. Uh, and it has several actions that we can take from the very first day in reducing the impact of
Mm.
our applications.
Great, makes sense. I will add, the details of your book in the description so people can actually take a look what's in there. So before we start our discussions and before we start discussing the techniques that we have to ensure, green software, let's define what is green software.
Green software is about building software that has fewer
Mm-hmm.
carbon emissions or even zero
Mm.
carbon emissions. So there are some other techniques where we use carbon offsetting. That is, we know that our applications consume electricity that is responsible for carbon emissions because it comes from burning
Mm.
oil
Yeah.
or coal. And then we also buy green electricity to offset the carbon emissions that our applications were
Yeah.
responsible for. This is a common technique that big cloud providers
Mm-hmm.
apply, and this is not really considered green software engineering. It's better
Mm-hmm.
than nothing. It's a good practice. It's a practice in the good
Yeah.
direction, the right direction. But green software engineering is not about offsetting carbon, but uh, it's about reducing carbon consumption, carbon emissions in the
Mm-hmm.
first place by applying techniques such as re-architecting our applications so that they consume fewer resources in the
Yeah.
first place.
Great. Uh, yeah, that sounds good. Let's dive deep into some of the top techniques that you would recommend people to think about while they are architecting the software.
I am taking a data-driven approach when it comes to which practices we need
Mm-hmm.
to apply. And according to data from the International Energy
Mm-hmm.
Agency, most of the electricity is consumed by data transmission
Mm-hmm.
networks. What we've seen in the past years is a trend of shifting from wired networks to wireless
Mm-hmm.
networks, mostly mobile networks like 3G,
Yeah.
4G, and nowadays 5G. And mobile networks are known to consume more energy, more
Mm.
electricity than wired
Yeah.
networks. And according to data, these data transmission networks consume more than 1% of the global
Mm.
electricity, whereas data centers consume 1%, a bit less energy compared to data transmission
Okay.
networks. So if we want to increase our impact as software engineers, we should start by reducing the data traffic that the data that we send over
Yeah.
the network, and also reducing the distance that our data
Mm.
travel.
I think these are two interesting points. So, as you said, like reducing the network hops, so the distance that your data travels, and then like sending less data. So these are like two parts, and we might have like different techniques. So let's jump into reducing the network hops, like reducing the distance that your data travels.
Yes, this is straightforward. Uh, it depends on where our end users
Mm.
are, the end users of our applications. First, we must look at where our end users are located, and if these users are located, for example, in
Yeah.
Germany, then we should ideally place our servers in the data center in a cloud region that is ideally in
Mm.
Germany, that is close to our end users of our applications.
Yeah.
That's the key thing here.
Yeah, makes sense. And I think that comes with like a cost benefit and the latency benefit as well, because if your users are if your data is where your users are, then they will get like low latency performance. So that is also better in that terms, right? So I think geo
Correct.
partitioning matters a lot here. So keep your data localized where it is going to be used. So this is about let's say like a web application that I'm serving some customers, right? But is it also applicable, let's say, within the distributed systems where you know multiple nodes are talking to each other for operating on some data like the big data systems, and then reducing the network hops might make a lot more sense also from the climate change perspective. And then data locality, as you said, I think it makes sense there as well, right?
It's clear that in distributed computer systems, things are more
Yeah.
complex, and there we can leverage CDNs, content delivery
Mm-hmm.
networks, to ensure that content is delivered to our
Mm-hmm.
users from the nearest
Yeah,
server.
yeah, that makes sense, and I think that is a technique that is used widely for serving static data over CDN, and that reduces latency, it saves cost, and ultimately it also helps you fight the climate change problem. Great. So I think the first technique that or tip that we should keep in our minds is that reduce the length or the distance that your data is traveling. So keep your data where your users are, where it is going to be consumed. And let's dive deep into the second technique. Like when we say like send less data over networks, so what do we mean? Are we saying that send only relevant data, or are we also going to talk about some compression techniques?
Uh, you're spot on this,
Mm-hmm.
Cavalier. Both techniques are valid here.
Mm-hmm.
So first thing is so far, cloud providers do not usually charge us anything when we upload data,
Yeah.
but only when we download data.
Mm.
That's why, as a practice so far, we weren't really interested in reducing the amount of data that we upload to cloud providers.
Mm-hmm.
It's quite common that we upload all the data we
Yeah.
have just in case we ever need
Yeah.
them. Uh, and it all starts by filtering out data that we don't
Mm.
need and only uploading the data that we really need to
Mm.
have. That's the first key thing we need to do
Yeah.
here, filtering out
Yeah.
data and uploading only what is needed. The second thing, as you mentioned, is compressing the data before sending it over the
Mm-hmm.
network. Therefore, reducing the usage of data transmission networks like mobile networks, and therefore reducing the energy consumed by these
Mm.
networks. We can have a big impact this way just by compressing our data before sending
Yeah.
them.
Yeah.
And the third and most important part is asking whether we really need to send data over the network and process them in a cloud
Mm.
provider. Nowadays, we talk about the
Mm.
edge, and it's all about processing data at their
Yeah.
source. So if you have, for example, a factory that is producing a lot of data coming from sensors, coming from cameras,
Mm.
it's more efficient if you deploy some servers
Mm.
locally in that factory and process data at their
Yeah.
source without having to transfer them over the network.
Mm.
It's better both from an operational point of view
Mm.
because you don't have that network latency of uploading data,
Yeah.
processing them, and then sending back the response,
Mm-hmm.
for example, if there is an alarm.
Yeah.
And it's much better in terms of green software when you don't send data,
Yeah.
but instead process them locally and send over the network only what is really needed.
Yeah. Yeah, that makes sense. So I think just to summarize what we have discussed so far is that first of all, like we as software engineers have a lot of power because we are building these applications that are used globally, and that definitely has like significant impact on climate change, like worse impact. So as you shared some data around 1% is used by the data networks, and it's really high, and then the other 1% is almost 1% is used by the data centers that we have. So I think it's extremely important that we think about it and try to optimize. And then since the data networks are consuming this much electricity, it is important that we think about like sending less data over the network, sending the data to closer locations by doing the processing at the edge, or by compressing the data so that the data size itself is small, and only sending the relevant data, and not just because it's there, it's cheap, does not mean that it's climate friendly. So I think it makes sense. So did I miss something, or we covered that?
No, that's excellent.
Okay, great. So that sounds very interesting. So I'm just curious here. So we work with a lot of databases, and nowadays like in-memory databases are also very popular. So is there some data around that, like if we store data on disk versus storing data in memory? So how does that impact, or what is the impact of storing data in memory versus disk when it comes to climate change?
It depends on the application and the patterns that you have, how often you
Mm-hmm.
read, how often you write. So I don't have a clear answer to your question.
Uh-huh.
There is an academic research that investigated the use of
Mm-hmm.
memory from different software applications, and they've identified that it doesn't really matter how much memory you use when it comes to the energy consumption.
Mm-hmm.
Applications that used more memory did not seem to consume more energy, more electricity
Yeah.
compared to others that used less memory.
Yeah.
Uh, Whereas reading from a database, depending on the hard disks that you use, may consume
Mm-hmm.
more
Yeah.
electricity. Uh, but the most important thing to keep in mind is that it all depends on the type of applications and how often they read or write data either to the memory or to the
Mm-hmm.
database. This is more important.
Yeah. Makes sense. And I think if we store the data in memory, then probably the processing itself is faster, and then ultimately it will also, as a side effect, you won't have to go to the network and call the database, and so probably that is also saving. So it's not clear which one is a better approach, and as you said, it depends on the application, right? Like storing data in memory versus accessing a disk-based database, and it depends on the application. It depends on how the data is used and how frequently the data is used, right?
Right. And your question reminds me of a very important topic that we often neglect. It's
Mm-hmm.
about measuring our applications
Mm.
and evaluating the decisions we take, different architectural decisions or improvements that we make to our applications. It's all about agreeing in the first place how you measure the environmental impact of your applications, and
Mm-hmm.
this must be a continuous process. With every
Yeah.
new build that you deploy, you must measure your applications and identify early on any changes in the environmental footprint of your application. This is a topic where there are a lot of discussions nowadays by different groups on how do we measure
Yeah.
the environmental impact of our applications,
Mm-hmm.
so that we all have some uh, common techniques and have some reference points that we can compare our applications.
Mm. Yeah, that's very interesting. So, I mean, of course, we can talk about these techniques, and we can also implement them. But unless we actually measure, like, what is the impact of these optimizations that we are making, I don't think we'll be in a very sweet spot where we are actually having a positive impact on the climate change. So, are there any tools out there which are helpful in your experience to measure the impact, or are companies working on building such tools?
There are some tools that were recently released by public cloud providers like Google Cloud and
Mm-hmm.
Amazon Web Services that allow us to measure the carbon footprint of our applications.
Yeah.
But these are fresh, and mostly I would say in an experimental phase.
Mm-hmm.
Uh, personally, I prefer to use the cost of our cloud applications as a proxy metric,
Yeah.
and use that as a reference point as to whether we are improving our application, making it more climate friendly or not. So it all boils down to how much resources your application uses.
Mm-hmm.
And since cloud providers charge us for these resources that our applications consume,
Yeah.
less cost means that our application has a smaller environmental footprint. And it's a metric that everyone can understand.
Mm.
It's a rough metric.
Yeah.
Maybe it's not as precise as the tools that public cloud providers are building to measure the carbon footprint.
Mm-hmm.
But it's something that everyone can understand, not only software engineers,
Yeah.
but the other stakeholders in our organizations can easily
Mm.
understand as well and track the progress of our
Yeah.
work.
Yeah, I think that makes sense. So we might not have very direct metrics at this point, as people are still trying to build. These tools will become mature in coming years. But as you said, like cost of serving an application or maintaining an application can be directly proportional to the impact it has on climate change. So that's a rough metric, but it's still good enough to start optimizing and start approaching into the direction of helping reducing the carbon footprint. So that
Yeah.
makes sense. And I think I was just thinking while you were answering the question. So I think it starts at the very low level when we are actually coding things. We are writing our algorithms, and then we are building applications. We are communicating over networks. So at each layer, I think we can make some decisions to make our software more optimized. So if I have to, put it very simplistically, in a simplistic manner, can we say that the more optimized algorithms that we have will have significantly less carbon footprint? Is it good to say that?
Again, it depends on your type of application and the data you work with.
Yeah.
And I'd like to bring an example to make this concrete.
Yeah.
We mentioned about compressing our data before sending them over the network.
Mm-hmm.
There are some edge cases of files that when we compress them, the compression ratio achieved may be 0%
Mm.
or
Mm-hmm.
1%. Some binary files like
Yeah.
videos, when you compress them. Uh, so when compressing these types of files, uh, you consume CPU to
Mm.
compress them,
Mm-hmm.
and you also consume CPU to decompress them on the other side when you
Yeah.
receive them, but you don't really gain anything out of compressing these
Yeah.
files
Yeah.
because in the end you haven't reduced the data volume while sending it over the network.
Mm.
So there is again academic research that proves that for some kind of files you may end up consuming more energy
Okay.
and not gaining anything by transmitting them over the network
Mm.
since they haven't been effectively compressed.
Yeah.
And what these researchers came up with, they came up with a very interesting
Mm-hmm.
approach of using AI, building a model,
Mm.
an AI model
Yeah.
that classifies the files to be sent over the network into compress or don't compress.
Mm.
So it takes this decision before sending it over the network. What kind of file is that? Should I compress it or not?
Yeah.
And it compresses only files where it will make some difference. For example,
Mm.
text files where you can achieve 80%, for example, compression ratio. And there it makes sense of spending this electricity to compress
Mm.
the network, send them over the network, and then decompress them because you've gained a lot of energy by sending a smaller volume of data over the network.
Yeah. So one other thing that comes to my mind is about the high availability for software applications that we have, and also fault tolerance. So we maintain these backup servers, and we also have replicas that become like an active member once the active is down and something wrong happens. So, what is your take on that? Is there a better way to handle, fault tolerance and availability while consuming lesser resources?
Sure. I'm happy to answer this question. You see, most data centers today, uh, in most data centers today, half of the servers consume energy without really doing anything.
Mm,
They don't do any actual useful work, but these servers just wait for a failure to happen so
yeah.
that they can take over and handle the requests.
Hmm.
Uh, See, most servers today are usually virtual machines.
Yeah.
When we wish to deploy new servers in a cloud environment, we deploy
Mm,
virtual machines. And virtual machines usually have a size in the range of several gigabytes,
hmm.
and it takes several minutes, 3 to 5 minutes, for a new virtual machine to start up. Whereas with containers have a size in the range of several megabytes, and it only takes a few seconds, 5 to 10 seconds, for
Mm,
a container to start up.
mm,
Uh, when we have a failure in a virtual machine, in a server, uh, then it will take several minutes for a new server instance to start. This
mm,
means that our users, the users of our applications, would have to wait for 3 to 5 minutes until a new server instance is up and running. And
mm,
clearly, this is not acceptable. That's why we have been adopting this practice of running warm standby servers or redundant servers so that they
yeah.
can immediately take over in case of a hardware failure and
Mm,
immediately serve customer requests.
okay.
We don't have to run redundant servers anymore. With the advent of
Mm,
cloud and containers, Docker ones or alike, we can containerize our applications and run only
mm,
a single instance for our application, a single container instance. And if that uh, container instance fails for some reason, for
yeah.
example, due
Mm-hmm.
to a failure in the underlying hardware, then we can quickly
Mm,
spin up a new container instance without the end users really noticing any failure,
mm,
any service disruption, because to
yeah.
start up a new container instance, it would only take a few seconds. And that's the key
Mm,
concept here, that by containerizing your applications, you can essentially reduce your energy costs by
mm,
approximately 50%,
okay.
by up to
Yeah.
50%,
Mm,
by
yeah.
getting
That's
rid
a
of all the redundant servers.
Yeah, makes sense. That's a great point because we have so many redundant servers because we want to make our applications fault tolerant. But as you said, we don't need that anymore. Like in many applications, because we have containerization and it takes like less amount of time to spin up a container as compared to a virtual machine. So that's a great point. That makes sense. Uh, let's talk about some specific programming languages. For example, if we take Java as an example, uh, are there any recommendations around the versions that we use or the frameworks that we use with Java to make our application more climate friendly?
Yes, sure. As I told you, my background is mostly on Java. I've been a Java developer for more than
Yeah.
a decade.
Mm-hmm.
And we have data from a research conducted by JetBrains that
Mm-hmm.
most Java applications still run on Java 8.
Mm.
And recent versions of Java, modern versions of Java, include
Mm.
many performance enhancements
Yeah.
that reduce the CPU usage and memory usage of our applications
Mm.
without us having to do anything. Just by
Yeah.
running our applications in a modern version of Java, like Java 16, we can benefit from all these performance enhancements
Mm.
and therefore reduce the environmental footprint of our applications.
Yeah.
And two quick examples of the features that were introduced. First is the compact strings feature that was introduced in Java 9 that
Mm-hmm.
reduces by 50% the size of Java strings comprising
Mm.
of Latin characters. By
Okay.
reducing the memory allocation for strings, the Java compiler does not get executed that often since less memory is allocated. And by reducing the execution frequency of the Java garbage collector, uh,
Mm.
we essentially reduce the CPU usage and therefore reduce the footprint of our applications. And there is also a performance improvement of approximately 10% that was measured for most Java applications.
Mm. Yeah, that's very interesting. So yeah, it's like staying up to date with the latest version in any programming language that you use might be a great idea because they keep enhancing the performance, doing the optimizations, and that eventually helps you make better software in terms of climate change. Um, let's talk a little bit on the framework side. Do you see like usage of the frameworks that we use with Java? Uh, uh, do they have any specific disadvantage when it comes to climate change?
Uh, for sure, it is recommended to adopt modern Java frameworks like Quarkus that
Mm-hmm.
is known to reduce the memory footprint of our Java applications. And
Mm-hmm.
it's a good practice compared to older Java frameworks that may consume more memory, more resources. But it's even better when we don't use any frameworks at all uh,
Yeah.
and rely only on the features provided by the programming language itself, by the Java
Mm.
language. There is academic research that proves that the memory footprint of the applications and the environmental footprint of applications is much
Mm.
smaller when we don't use any frameworks, but rely only on the features provided by the language.
Mm.
Of course,
Very interesting.
it comes with a trade-off. All decisions
Yeah.
like this one have a trade-off that it may
Yeah.
take us more time to build new features without a framework.
Mm. Yeah, I think that's a good point, and I think it depends on the type of application you're making. But if there is a choice that you can live without using a framework, I think that's the best thing to do. Great. So yeah, I think that makes sense. Um, let's talk about some of the tech stack decisions that we can take. Like there are some languages that might be more uh, eligible for having less carbon footprint on the in the software application. So are there any recommendations on programming languages, some of the versions that we have?
Sure. There is some very interesting research from universities in
Mm-hmm.
Portugal that assesses all the programming languages we
Yeah.
have. So they came up with some benchmarks, some algorithms that are implemented in all the programming
Mm-hmm.
languages, and they've run tests. They've run these benchmarks in all the programming languages and measured the energy that each language consumes
Mm.
while performing an algorithm.
Okay.
And they found out that compiled languages like C and C++ consume less energy than other languages, such as interpreted languages like Ruby, Python, and Perl.
Mm-hmm.
And it was really impressive what they came up with. They found out that C uh, consumes way less energy than Perl. Perl
Mm-hmm.
consumes 80 times more energy than C.
Wow.
80,
Yeah.
that's 80 times more energy.
Yeah. That's a very interesting metric. I mean, 80 times is a huge difference, and like knowing this, I'm really like looking forward to all these uh, researches that happen and come up with these fascinating numbers like 80 times more carbon footprint or more energy consumption as compared to C or C++. So in general, I think it's safe to say that compiled languages are better in terms of climate change as compared to interpreted languages, right?
Yeah, and if we can think of some kind of prioritization, as you
Mm-hmm.
mentioned, compiled languages are the most energy efficient ones. Then we
Mm-hmm.
have languages running on top of virtual machines like Java and .NET.
Mm.
And the last ones and least energy efficient ones are interpreted languages like Ruby, Python, and
Mm.
Perl.
Yeah, makes sense. Uh, Great. Let's talk a little bit on the advent of cloud and how it has helped uh, being more climate friendly. So, uh, like moving to a cloud is better than running our data centers. I mean, it depends again, but cost wise, if you're just starting up and you don't have to buy servers, you can just use a cloud provider. But I think in a way that is also like being cost effective and also climate friendly, right? So because you have more reusability when it comes to the cloud provider, so the cloud provider using the same machine to serve different applications. So what are your thoughts on that, like using a cloud versus running our own data centers?
I like to think of the example of using our own personal car
Mm-hmm.
versus public transportation.
Yeah.
It's the same thing. So you either have your own servers in your own data center,
Mm-hmm.
or you use the infrastructure provided by public cloud providers as if it were public transportation.
Yeah.
It's very much the same thing. Public cloud providers can achieve higher utilization
Mm.
of the underlying hardware by running many applications in parallel, many times from different customers, from
Mm.
different users. And that's how you can achieve higher utilization and therefore smaller environmental footprint by using only what you really need. So
Mm.
that's essentially the spirit of
Yeah.
uh, your applications use only the percentage of hardware that they really need.
Yeah. Yeah, I think I like the analogy, like using a private car versus a public transport, and that suits really well when we compare, private data centers versus cloud providers. So I agree on that. And as you said, when you're not using the application, you don't need to consume the resources. So scaling up and scaling down is like natively supported in cloud environments, whereas in data centers it's a little bit complicated. uh, Coming like talking about scaling down and scaling up, I think serverless is a big thing now, and it helps. So I was talking to Jim Walker from Cockroach Labs in my previous episode, and he talked about the consumption model. So serverless is more like a consumption model, like how you consume your services from the cloud provider, and it helps you reduce the cost. But what is its impact on climate change?
Yeah, I'll bring again an example related to cars.
Mm-hmm.
It's one of my favorite
Yeah.
ones. As you know, modern cars have this stop-start system.
Mm.
When you are in front of a red traffic light, this system stops the engine so that it doesn't consume any fuel and therefore does not emit any carbon anymore,
Mm.
therefore making our cars more efficient. Whereas with older cars, the engine would continue working,
Yeah.
would continue consuming fuel, even though it was not really needed. The engine
Mm.
was actually idle uh,
Yeah.
when being in front of a red traffic light. The same thing happens with many of our applications. We have
Mm-hmm.
applications running on servers that don't serve any actual requests. They
Mm-hmm.
just wait for a request to come.
Yeah.
And if you notice that you have an application that is most of the time idle,
Mm.
waiting for an event, uh, to be triggered, or for a request, an HTTP request to come, and this doesn't happen very often, then this is a sign that you must have your application re-architected to leverage this serverless model,
Hmm.
which works very much like a stop-start mechanism.
Yeah.
Uh, Cloud providers run serverless functions
Hmm.
only when we have an incoming request or an event. And after this event or request is processed, then this function, this serverless function, is stopped and therefore does not consume any resources.
Yeah. Yeah. That makes a lot of sense. And again, I like the analogy. So the start stop functions in the modern cars that they have, you can just stop when you don't need to. As for example, in the traffic light system. So if you're waiting on a red light, just stop the car. So you're not consuming any fuel. And it's similar to the concept of serverless. So if you're not serving any traffic, it's best to scale it down. You won't have any servers. So that makes a lot of sense. So thanks for sharing that analogy.
Yes, still, not every application is suited for the serverless model.
Yeah.
We need to consider, as I said, is it an application that is idle most of the time?
Mm.
Can we re-architect it into a serverless function or into one or more serverless functions? We
Yeah.
usually have to break an application into independent serverless functions.
Mm.
So there is some effort there. It doesn't come for free. There is some
Absolutely.
development effort,
Yeah.
uh, but it can certainly pay off both in terms of costs,
Mm.
operation costs, and also in terms of a smaller environmental footprint.
Yeah. That makes sense. Uh, yeah, I think it depends again, as you said, like it depends on the use case. It depends on, that the traffic pattern, I guess. Like if you have like a constant traffic throughout the day, then maybe serverless might not make sense, might not save cost, and might not have like a positive impact on the effect of climate change. So that makes sense. Any typical examples that you have that might not have a good impact if they use serverless, for example?
Applications that are constantly receiving requests, quite many requests,
Hmm.
may not be the most suitable ones for serverless functions. You don't gain anything there by shutting down your serverless functions and starting them again.
Yeah.
So in case of high volume traffic throughout the day,
Yeah.
maybe this is not the best way to go.
Hmm. Yeah, that makes sense. Great. What is the future of green software engineering? So, as you are involved in this effort, you might be talking to some other leaders in the industry or some companies that are working towards making the green software development better. As you said, there were some research going on. Some companies were building tools. So, uh, how do you see the future of green software engineering?
For sure, green software engineering is a hot new topic where we
Yeah.
can all contribute and make a big difference.
Mm-hmm.
Personally, I find it very exciting.
Hmm.
The most important thing we can all do is include it in our discussions. We take decisions for our applications on a daily basis
Yeah.
and examine non-functional requirements like scalability,
Hmm.
maintainability, portability, all these ilities. Uh, we frequently talk about them without anyone explicitly asking for them. We don't usually have a customer
Yeah.
asking for maintainability or portability. It's our concern, our software developers, to
Hmm.
have these discussions around these ilities.
Yeah.
Sustainability is the newest ility.
Yeah.
And the best thing we can do is include it in our conversations.
Hmm.
And we frequently find out that decisions we make uh, can be better made when we think of sustainability. For example, take for example Availability. It's one of the ilities we discussed. Do we really need to achieve 5 nines in our application, or could we also work with 3 nines?
Yeah.
And by having the discussion about sustainability, it turns out many times that the 3 nines may be more than adequate for some types of applications. And you don't really need to spend these extra resources, consume these extra resources to achieve 5 nines of sustainability,
Yeah.
of availability, sorry, and 5 nines of availability.
Yeah.
And when you have these discussions around sustainability and have this concern in mind, then many times you can take better decisions in the other ilities, in the other non-functional requirements.
Yeah, yeah, that makes sense. So I think, as you said, it's really important to talk about it and include these concerns into our conversations while we are building new applications or talking about refactoring an application. So if we are approaching it from this perspective and not only cost, not only optimizing on speed, latency. Of course, these will have some side effect, like a positive side effect on climate change. But looking it from a perspective of climate change will definitely help here. And so I think the analogies that you have shared and the techniques that you have shared are going to be really helpful. I think some companies are already putting a lot of effort when it comes to sustainability. And then sustainability, I guess, has like two parts to it, right? Like sustainable in the sense you're able to generate enough revenue, you're able to cut down on the operational cost. So but it also has some side effects on climate change. For example, the e-commerce company that delivers you the packages, they try to bundle your orders together. For example, for the same pin code, so they don't have to give multiple trips or have multiple trips to deliver your package. So all these small decisions that companies are making, plus the techniques that we talked about today, I think these are going to be extremely helpful in being more aware of the impact of the applications that we build on climate change. Great. So let's summarize what we have like discussed so far. Uh, and I think it is really helpful, and it's an interesting perspective to look at software engineering. So let me know if I missed something. I'm just going to try to summarize
Sure.
the key things, and and also feel free to interrupt if I miss something. So we started talking about the approach of green software engineering, like what it means, why we need to be more conscious, and I think you shared some numbers around how much, what is the percent of data networks that are using in terms of electricity and the data centers. So we want to optimize our network, like the data that we send over the network. So we should be conscious on sending like less data, only the relevant data to the network. And then keeping the data where it is used is extremely useful in reducing the network traffic. And I think third one was to compute the data and on the edge. So a lot of traffic, a lot of noise that you don't need might get filtered out at the edge, and you will only get the relevant data. And I think a lot of IoT applications are using these kind of patterns, right? And then there are compression techniques that let's compress the data and then send it over to the network, so it uses less bandwidth. But again, we also talked about the trade-off. Like sometimes compression ratio would be not ideal for you to get that benefit. So be cautious on that as well. And I think then we talked about the consumption model, like how you consume the services of a cloud provider. It doesn't mean if it's for free that you should use it. It should be required. So let's also take some conscious decisions there. And then we also talked about serverless, which makes sense. And you gave some beautiful analogies about, using cloud providers versus data centers, which is like using a public transport versus using a private car. And then for the other one, which is on serverless, so it's the start stop button. So it's a good mental model to understand how it can save cost. Uh, did I miss something, or do you want to add something more?
No, that's excellent. An excellent summary. Thank you.
Great. Awesome. So I think I enjoyed a lot discussing all these techniques with you, and like before I reached out to you and talked about this topic. I wasn't really thinking about software architecture from the perspective of climate change. So thanks a lot for bringing that awareness. And I'm sure after listening to this podcast, our viewers will also become more curious and will start making decisions that have positive impact on climate change. So um, thank you for sharing the insights with us, and I'll add all the details in the description about how people can learn more about green software engineering and how people can be more aware. So yeah, thanks a lot for coming on the podcast. I
You're
really
welcome,
enjoyed.
Cavalli.
Cool. Thank you.